What if our most basic assumptions about the universe are just wrong? Think about it. What if light, the absolute foundation of how we see and measure the cosmos, doesn't actually travel in a straight line? I know, it sounds like pure science fiction, but this exact question might actually hold the key to solving one of the most mathematical mysteries about energy in our universe. Welcome to The Explainer. Today, we're unpacking a really bold theoretical physics paper published in August 2026 by Dr. Ahmad Rihan. It's called Spiral Photon Propagation and the Rihan Atomic Model. His research attempts to solve a huge cosmic puzzle by totally reimagining the fundamental path of light. We're going to break down these complex concepts so you can see exactly how this paradigm shift works. To keep things super clear, here's our roadmap for today. 1. The cosmic energy mystery. 2. The Rihan Atomic Model. 3. Spiraling through space-time filaments. 4. Einstein's coin reimagined. And finally, 5. Testing the helical hypothesis. Let's dive in. Section 1. The cosmic energy mystery and the big problem with curved space-time. Okay, so here's the core issue we're dealing with. In classical physics, energy conservation is a bedrock principle, right? In flat space-time, what physicists call Minkowski space, the math balances perfectly. It's like a totally reconciled checkbook. But as soon as you move into the curved space-time of Einstein's general relativity, things get messy. The math technically satisfies covariant divergence, sure, but it completely lacks a transparent, dynamical mechanism to show how local energy conservation looks identical from the perspective of a traveling photon. Basically, we're missing the geometric reason for how energy perfectly accounts for itself across the cosmos. Section 2. The Rihan Atomic Model, redefining the atom and space-time. To fix this massive accounting error, we need a totally new framework. Enter the Rihan Atomic Model, or RAM for short. This completely flips the standard grade school model of the atom on its head. Instead of empty space with tiny point-like particles whizzing around, RAM views the atom as a system of concentric electromagnetic Gaussian surfaces. You've got protons revolving on the inside, electrons on the outside, and they're locked in this dynamic equilibrium by a vanishing net momentum velocity balance, which basically means the system is completely stable on its own. No need to invent extra short-range forces to explain why atoms don't just collapse in on themselves. And this brilliant rethinking scales all the way up. We usually picture spacetime as this vast empty void where light travels as pure plane waves. But RAM proposes that spacetime itself is an interlaced electromagnetic filamentary network. Think of it like an incredibly fine, invisible mesh spanning the entire universe. In this view, our three-dimensional space actually comes from the interlacing of these filaments. Time is just the collective vibrational phase of the mesh, and atoms, well, they sit perfectly right at the nodal intersections of that web. Section 3. Spiraling through space-time filaments, the helical photon hypothesis. If space-time is an actual electromagnetic mesh, how does light move through it? The paper hypothesizes that photons, because they're pure electromagnetic excitations, are literally physically constrained by this mesh. They can't just detach and fly blindly through an empty void. They are strictly bound to the filaments. So this begs a massive question. If a beam of light is essentially forced to follow these fundamental filaments stretching across the universe, what exact path is it taking? The answer? A helical trajectory, a spiral. Dr. Rihan argues that a photon revolves around these space-time filaments much like a charged particle spirals along a magnetic field line. And why does a corkscrew motion matter so much? Because it automatically adjusts the local energy transport, what we call the Poynting flux. It ensures that the continuity equation keeps the exact same form, whether the photon is traveling through completely flat space or heavily curved space. This spiral motion is the missing geometric mechanism we've been looking for. Section 4. Einstein's coin reimagined, rethinking mass energy equivalence. Dr. Rihan uses this fantastic analogy in the paper, describing energy and rest mass simply as the two faces of a coin. In this new framework, there is only a single conserved invariant quality in the universe. Whether it looks like energy or looks like mass to you, well, that's entirely dependent on your geometric perspective. We all know E equals mc squared, right? It's printed on a million coffee mugs. But applying this helical photon hypothesis directly reinterprets this famous equivalence. The value you measure, whether it's energy or mass, isn't an absolute trait of the object itself. It depends entirely on your angle of view relative to that spiraling photon we just talked about. Imagine looking straight down the barrel of one of these filaments. From that longitudinal perspective, you measure primarily longitudinal energy. But if you shift to a transverse view, meaning your perspective literally encircles the filament, you measure an effective rest mass. And that mass arises purely from the circulatory kinetic energy of the spiral motion itself. The really cool part? The two measurements are related mathematically, and they completely reproduce Einstein's equation simply based on the pitch of the photon spiral. It's just an incredibly elegant solution. Section 5. Testing the helical hypothesis, moving from theory to the real world. High-level theoretical physics is fascinating for sure, but to be true science, a hypothesis needs testable implications. The paper doesn't just leave us with elegant math, it outlines specific observable metrics. Scientists can look for curvature-dependent modifications in the orbital angular momentum of light. They can use atomic clocks in orbit to measure gravitational redshift corrections. They can even look at cosmological energy levels, or build scaled-down analogs right here on Earth. Let's look closer at that laboratory option, because it's incredibly grounded. Engineers could actually create physical, nanoscale analogs using materials like graphene, specifically designed with helical defect channels. Then they fire light through them and test the conservation of energy under controlled curvature. If the energy stays perfectly conserved across curved and flat channels, this spiral photon hypothesis gains some massive experimental backing. And the implications of this scale up beautifully. On a macroscopic scale, if this interlaced network carries a non-zero fraction of the cosmic energy density, it might actually replace our need for exotic, mysterious, dark energy altogether. Energy flowing along these intergalactic filaments would remain locally conserved whether the universe is expanding or flat, potentially solving one of the absolute biggest headaches in modern astronomy in one fell swoop. We've covered a lot of ground today, moving from atomic Gaussian surfaces all the way out to the edges of the cosmos. So I want to leave you with this final provocative thought to ponder. If everything around us, from the tiniest atomic surface to the vast dark spaces between galaxies, is built on an interlaced web of filaments, and the light we use to see it all is just a spiral, what else about the fundamental nature of reality are we currently looking at completely upside down?